Oh, okay, thanks. Right, good evening, everyone, and welcome to CAWASA Wednesday webinar number 5.
What?
And this afternoon, sorry. Apologies, someone is, okay, let me start this again. My apologies. Someone was speaking over there. Please keep your microphones on mute. Right, so good afternoon. Welcome to CAWASA Wednesday webinar number 5 of the 2022 series. This evening, we are joined by a special guest who is a senior technical expert holding a master's degree in environmental process engineering and a bachelor's degree in mechanical engineering with 21 years of professional experience in IFI Finance International projects in the field of domestic and industrial wastewater treatment and sanitation, with project cycle experience comprising of project and business development, feasibility studies and design appraisals, implementation planning and management, operation and maintenance. And with broad experiences in developing and leading water sanitation, environmental implementation and capacity building projects, engineering systems for wastewater treatment and reuse with focus on nature-based solutions, establishment of public wastewater management and infrastructure services at city level, city sanitation planning, capacity building for water utilities and municipalities and sanitation planning and implementation in peri-urban spaces. And so this evening, I have much pleasure to welcome Mr. Andreas Schmidt, who is now bracing for some stormy weather in Hamburg, Germany, or near Hamburg, Germany. So welcome to you, and on this stormy evening for you.
Thank you very much. Hopefully everything is going to be fine. Indeed, there is a bit of storm here. And the pleasure is also completely on my side. I'm very happy sharing some experience, lessons learned, giving some ideas. Hopefully I can give you some added value. I have chosen the topic of biogas and wastewater, which is quite interesting topic and coming more and more up, A, because of waste to energy desire, and B, also on the climate change mitigation measures. And I know biogas and wastewater treatment plants on the big treatment plants, that works quite well. And in Germany, Europe, we have wastewater treatment plants which are now producing energy more than actually they consume by the help with biogas and even wind turbine. But if we want to look at it at smaller systems where things are in the sector not yet so developed, where we have smaller municipalities or smaller grids and treatment plants, still, is there an option with biogas? And here I want to share some experience over the past years. And the content so far, a small introduction of UrbanWaters, which is our consulting firm. Very rough idea about the biogas potential of wastewater, then domestic wastewater and biogas system, simplified sewer and biogas, and extracting biogas from lagoon. So it's a bit more of a technical topic. I'm not going too deep. I hope I give a little bit an overview. I hope I can give some ideas, some inspirations, and so on. But I don't know so much your background. So let's see. And if you have question, how is it, Ignatius? how's usually it's at the end or in between. Either way, it's fine for me.
We can put the questions in the chat, and if anything comes up, we can let you know.
Okay, so I'm sharing the presentation mode. Then, okay, I see the chat. If you can help me in the end would be great. Okay, so let's move on. Does it work? Okay, so UrbanWaters is actually a spring off from Border. Border is an international organization, and I have been working for more than 14 years with Border. They have in Latin America a base in Mexico as well, and Mexico, Cuba, Nicaragua, and in this area. I have never been in this area, unfortunately. I worked for Border mainly in Africa and Asia. In 2019, we made a spring off with Border Solutions and a management buyout, which called then UrbanWaters. What we do, it's mainly we dealing with urban water sanitation planning. So we assisting development banks, municipalities, ministries, how to select the right water sanitation interventions. We assisting them planning methodologies, assisting them in developing investment plans, and as well how supporting them in implementing it. So then we have a strong stake in technical solution, mainly nature-based solutions, because our background comes a little bit. We starting introducing wastewater management usually in areas where it's not yet there, where it's water now somehow served, but if you provide water, you generate wastewater, and often utilities have not yet the capacity to deal with wastewater sanitation, and often this is where we're starting and developing the sector. And then we, of course, we're not starting with high-tech technology, rather starting with smaller, low-cost solutions. So this is a bit of our background, and of course, this project management. This is on the right-hand side, just our core team, a quite international team. We are not yet so much in Latin America, but we got now assignment with Belize on lagoon systems. Looking forward to this assignment. Otherwise, we are mainly working in Africa and Asia, and our clients are development partners, and our end beneficiaries are usually ministries, utilities, municipalities. So back to the topic. There's always a desire on turning waste to energy, and it's wherever we introduce wastewater management, we started honestly off with biogas. People saw the need to utilize these resources to turn it in something useful, and this desire is really appreciated. But we need to also acknowledge it is not that easy, mainly from the sustainability point of view. Technically, everything is possible. So, and if we're looking at the sustainability point of view, and this is this slide, it's also a little bit somehow the conclusion of this whole presentation. There's on the top line, sustainable biogas value chain is actually when the revenue is higher than the cost. Sounds simple. In reality, it's often not the case. Meaning the expectation and for revenue and turning waste to energy and covering the cost, it's much higher than the reality actually can feed this expectation. So, and that's why it's quite important that we a little bit understanding the value chain. We got on the right-hand side, on the left-hand side, sorry, our feedstock, our resources, which could be generally from biogas production, food waste, municipal food waste, any type of food waste. Then wastewater, which are, let's say, who deals with water and wastewater, it's, let's say, the most interesting part. And aqua waste, which is very common from the feedstock from any other type of agriculture waste. Then we have somehow in reactor where we're producing the biogas with the help of microorganisms. Then depending on the utilization concept, which is on the other side, we want to use the energy for cooking, for heating, electricity production, or even for mobility purposes. We need to see how, in what type, and what quality we're getting the biogas, and that is determines in the end how we need to convert the biogas and perhaps also declean it. So, and as you could imagine, if we want high quality of the gas, then it also means we have a lot of input we have to give to convert, to clean, to produce, in order to make it somehow feasible for electricity production and so on. But the most easiest way is actually for biogas utilization, it's turning it into heat, just burning it, because you can just take the gas straight away from, from the digester and turning it in heat. But you need the concept to make biogas or the heat or whatever into money. So electricity you can sell to the grid theoretically if you got a bylaw who allows you that you can sell to the grid. And I have seen big biogas plants, they signed a contract with electricity supplier, but in the end they never got paid or never got paid in time, or they have not get sort of the source side and they could not provide the energy in a stable way. Then the tariffs was cut down. So turning food waste into biogas, it's one step, but turning the gas in a cash flow, in a sustainable cash flow, this is actually the most difficult part, and often it requires in a certain enabled framework from financial instrument, a law system, and also technology provider to make it actually happen. And whenever you go in new countries, in your working area, looking for this opportunity, take this very serious. Ensure really you have the enabled framework that allows you to turn gas into cash. And if there is an industry, it needs just heat, sell the heat. Don't go for the most expensive like electricity or even converting into gas. In the gas bottling, even the gas bottling is one way of doing it, but it needs high quantities and sophisticated technology. So, and if we're looking at the wastewater part, then we're dealing actually with a food stock which has the lowest energy density we could actually imagine if we're talking about biogas. So if we're taking 1 cubic meter of raw wastewater from municipal wastewater, depending on the conditions, depending on strains and on the reactor, we might get 150 to 250 liter gas out of 1 cubic meter. If we're taking sewage sludge, you know, from either from the primary settler or even from the activated sludge bag, you dewater, then you get 6 to 7 cubic meter biogas per cubic meter sludge, higher concentration of energy. And if you look at organic waste, which is more a solid waste, then you got 50 to 70 cubic meter per ton out of it. So that's we need to understand that actually the energy density in wastewater is relatively low, but still it's possible. And of course, we should not aim, we need to look how most sustainable way we can turn and we can utilize the gas. And we need also to consider that wastewater is a source for greenhouse gas emission. It's for methane, it's for CO2, and it's also for laughing gas. And if we are also able to collect the gas, which it can be generated from wastewater, we could potentially, through other financial instruments, generate additional income through the greenhouse sales. But the topic was a bit looking at smaller treatment plants. I mean, smaller treatment plants, let's say around up to 1,000 cubic meter, or everything below 1,000 cubic meter wastewater to be treated per day. To what extent does it make sense? And here in this presentation on this slide, I just saw, okay, what is actually needed, how much gas you need to run economically a machine who cleans and bottles the gas in like LPG cylinders. So you can put it, you can cook on it, you can even put it in the car. So it's an equal product to the LPG gas. You would need around 5,000 cubic meter wastewater a day as a minimum to generate somehow sufficient gas. So if you have a CPH, that can co-generator to produce electricity, if you want to run it 100% on biogas, the small, let's say, they are even smaller, but usually I calculate now for around 45 kilowatt hour engine. If you want to run it on 100% biogas, a 45 kilowatt engine generator, you need at least 1,000 cubic meter biogas, wastewater, wastewater a day. If you run it on a coal fuel, that means diesel and biogas, then you can also go less. But you need, the message is you need a lot of quantity in order to run one of the high value biogas utilization concepts. That means, honestly, for smaller systems, the most effective way it's heat for cooking purposes. It's smaller for institution, household level. We have done, for example, community sanitation center, or even a sanitation center at bus stops, at public places, putting a biogas plant there, generating gas for generating heat and warm water so that people can take a shower. So, and the people were willing to pay for the shower, and automatically you got a cash flow who would finance your investments. So the topic was looking a little bit more on smaller wastewater treatment plants and what is possible. And I would like to share some concepts. And one, it's on the domestic level. Hold on. Okay, got it. So if we looking not for municipality, if we're having an on-site system, meaning the households, if they have a little bit land and we cannot connect them to our sewer network and they're looking for their own septic solution, we could convert septic tanks into a small biogas plant. And this concept has been done many thousands times in Africa, in China and Asia. This really small systems where the wastewater and as well sometimes kitchen waste goes into the biogas plant, gets partially treated in the biogas digester, which is underground, a small constructed wetland. The overflow goes then in some irrigation system, and the biogas can go back in for cooking purposes. So this system, I have been working in South Africa. It's becomes quite common, and artisans and small companies have specialized themselves manufacturing now ready-made small septic tanks with a biogas function involved, and as well sometimes with post-treatment. So a really small package plant with biogas. And the application of those small systems is usually, let's say, smaller, 10 cubic meter a day for households and institutions. They're generating 200 to 3,000 liter biogas per day, mainly for cooking and heating water. The effluent goes irrigated or infiltrated, or sometimes also connected to public sewer. That means acting as a pre-treatment system. The efficiency, of course, it's quite limited, 50 to 70%. But if you connect the effluent to a wastewater sewer system, could also be an advantage if you have a solid-free system, which I'm saying a bit later. Cost-wise, depending how it's been built, is it brick-built or prefabricated, or how complex the system, how big is it? The smallest you can get from $600, and the biggest around $2,500, brick built or prefabricated mass production, and very common, as I said, in Asia, India, China, and Eastern and Southern Africa. Lessons learned from this concept is it's a quite effective system in combination with the on-site septic tank. And septic tank as well produce some methane if we're able to capture it. Then we also do something good to the environment, and we're giving a certain benefit back to the community. Solid waste and increase the biogas, but we need to acknowledge it's also increased the nutrient, that means nitrogen, phosphorus, and sulfurous in the effluent, which might be if you infiltrate in the ground, not always good solution. Usually it covers the cooking energy demand from one household. And from the government side, for this kind of on-site system, it requires a commercial supply chain for this kind of products and after-sales service. So don't import, really, if this should come in place, it's important you have locally experts, a supply chain, and after-sales service. And we always recommend, also from the government side, that the products and operations should be standards, and it should be publicly monitored. Another concept at a little bit on the municipality level, but still small scheme, it's combining simplified sewer with biogas. There's a big discussion, what's a simplified sewer? One concept is actually, let's drop the solids at the decentralized level in the sewer network and having most of the sewer network free of particles and solid waste. So we design sewer networks that we have enough energy, hydraulic energy, to bring the solids in the sewer system from A to B. And this requires diameter, a certain slope, and a very smooth implementation. But in the end, it's also a lot of headache. If we can drop the solid waste at decentralized level, having a pre-treatment, we're reducing the COD for the main treatment, reducing TS, and having a much more simplified sewer network. Even if you don't put it so straight, it doesn't matter, because it cannot settle anymore. You settle your solids controlled in the system. And if you like, that we have done in certain communities, you can also extract the biogas, and let's say some caretaker, they can utilize it, or you give it to a restaurant. So this is a concept we have implemented in Zambia, and together with 3 utilities. We're protecting the advantage of the system where we're protecting pumps. Yeah, because all the solids, even the trash, were nearer at source and not at the pump station. We had no wastewater solids, hence the pipes could be laid with less gradients, not that deep as usually required. That means less construction excavation cost. We had much less cleaning and unclogging purposes. For example, if people have not so often constructed sewer networks, then usually the technicians are not so familiar with making the system tight enough. And if you lose water, then the sludge and the solids will be trapped in the sewer system and start clogging, and you need to flush. If you do it controlled, even if there's mistake already on the construction side, on the sewer network, it's forgivable. Because you have controlled the sludge. You treat already up to 70% of your COD at decentralized level, meaning also your wastewater treatment plant can actually be smaller, and you can have the opportunity to extract the gas. And as you can see here, so the mixture of water and the solids coming in the inlet, dropping down, and then the outlet is mainly solid free. What will happen if they don't dislodge the digester? Then, of course, sludge will also wash out, but the sludge is not anymore the big particles and the paper and whatever. It's an only very fine particles, which can easily flow with the water. So in principle, we got here our raw wastewater. From the maintenance point of view, we need regular have a look at the inlet, usually monthly removal of scum. We usually connecting to one settler 20 to 50 households. The size, it's 20 to 50 cubic meter. Usually we're putting it next to the street, finding the space in the community, sometimes a bit challenging. So then also the cooking, yes, having biogas is fine, but only we say 10 households can serve the biogas for one household. And then there's also a bit the question, which household gets the biogas? And so there's a bit of community work, involvement, participation really required. And we usually say, okay, the utility should come with a vacuum truck and empty once or every 2 years the digester and taking out the sludge. So some are the principles. Here is a little bit implementation concept. This is a community in the center of Zambia. It's a low-income community. Here we connected 120 houses, and this is the collection pipe is shown here, which is nearly 4 kilometers. This in the community. We installed 4 biogas plants, one is here, one here, one here, and then at the final. But this was actually not needed more. But main day 3, they do most of the job. Then we got the wastewater treatment as well with a constructed wetland. And in the end, we put in the natural wetland a banana plantation before it goes into the final water body. So the biogas settler, they're producing 0.5 to 1 cubic meter biogas every day. And through this constant water flow, we're reaching an amazing maintained concentration of 75 to 80%. And we have reduced in the system already in the sewer system 50 to 65% of the COD loading rate. Okay, so and another concept, and then we're almost already through and I'm open for discussion. It's a little bit more on the treatment side. Lagoon, there is a big discussion or ideas about covering wastewater lagoons and collecting the biogas, which is absolute makes sense, especially if you focus on the first anaerobic lagoon, the pond. Usually only the first one, the other are the facultative or the aerobic. They don't need it, but the first lagoon, which is usually anaerobic, it absolutely makes sense to cover it. You don't have odor, you're getting mosquitoes, you have no greenhouse gas emission, and you have the ability to capture the gas. So there's mainly 2 systems have been, let's say, available. One which you see on the top, which is, this is really a big one. You have this membrane with integrated gas storage. So it's integrates, as you can see, underneath it's the gas storage. It's usually a double membrane. There's also some few with a single membrane, but usually there's a double membrane. That means there's another membrane underneath, which is going up and down with the gas content, with the gas pressure or quantity. And the outside membrane gives just the shape. But to maintaining the shape, you need usually an air blower or gas blower, which constantly blows air in it, that you have the shape. Because if you don't have the shape and you got heavy rain, if you got wind, it will create a lot of tension on the membrane. It might crack and break. So this is a bit a disadvantage. And as I said in the beginning, we working usually in area where the sector is not yet developed, where often electricity is a challenge to have constant electricity supply. So we came up with a Dutch company on the floating membrane concept, as you can see on the bottom. This is a project in Bangladesh. This is wastewater or in sludge lagoons we covered with a floating membrane. So the floating membrane floats really on the surface, and it's a single membrane, and it doesn't need electrical power to keep anything in shape. So this is the main advantage. And here a little bit more in detail. The disadvantage is you don't have the gas storage, in fact, pro and cons. So you need actually an external gas storage, sorry, and the gas pressure is very low. Although on the other hand, if there is any damages on your membrane, you're not losing the entire gas. As you can see, we can collect the gas as many points as we wish in a very simple way with simple domes which are integrated in the membrane. And if we got a leakage somewhere here, all the others can still collect the gas which is collected underneath the membrane. And usually it's enough, the pressure, which is below 5 millimeter water column, to run a torch. But if you want to have any other system, even for cooking, for lighting, or here we generating around 80 to 100 cubic meter gas a day, we need to be pumping it, putting it into external gas storage, which has different type of design as possible with the help of a small blower. So this is needed, but we don't rely on electric energy to keep any shape, and if we have damages, it will not affect the entire system. We can put it on the existing membranes. We can put it, as you can see, they're just placing it in the this is the liner, and then they're putting, I think this is also the liner, but the floating membrane, it's actually looks very much the same. What needs to be considered, it's the stormwater, because when heavy rain comes, the water will pool. So we have, as you can see a little bit here, and in other points, we need to drain the water. Otherwise, the water will push out the liquid. And with this slide, I know you also had your hard working days behind you. I would also close this small session, and I'm happy for any ideas, feedbacks, questions. Thank you very much.
Thanks, Andreas. Are you there, Ignatius?
I was on mute, sorry.
Okay.
Okay. Right. So thank you very much. Do you have any questions? Where are my participants?
They're all shy. Ezekiel, you can have one or two.
Okay, Shannon is on. Go ahead, Shannon.
Yeah, good afternoon. Question. In regards to the waste that we use on the biogas, do we separate the grays and the black waters, or is it like a combined system?
For which system?
The influent to harvest the biogas.
Yes.
Do we use both the grays and black waters, or is it just, or do we separate them, or is it like a combined usage?
Both is possible. Both is possible. Usually, let's say if you don't have a separate sewage system, then you have gray water and black water both. If you're able to separate gray and black water, it's from the biogas point of view, it's even better because you have more energy and less volume if you have just dealing with the black water. And there's also a system working with the vacuum system and then having a digester and producing gas. So both is possible. In the cases I have presented, mainly they are mixed. At household level, we have also installed systems also which are separated, black and gray water.
Okay, thank you.
Welcome.
Andreas, every system is obviously different, but you're working in countries where, similar to the Caribbean, cost and resources are limited, cash and resources are limited. What sort of costs are involved in putting in, say, the last system with the floating membrane?
The floating membrane, let's say okay, they have the excavation cost for the pond system, depending on the ground condition, depending on the depth and the sealing method. But it just from the floating membrane costs around $12 to $15 per square meter. And if you got the double membrane, you are up to $30 per square meter. So it's much more cost effective than the double membrane. And the material, it's woven PVC. It's very strong material, but usually we're putting UV protection shade net on top.
So generally, and again, it depends on the country, I guess, but if you were to install one of these, what would be the payback time? Because you're saving money by, recapturing gas.
The question is how to get to turn again the gas into cash.
Yeah.
And this depends very much on the local context. So in the case we have this lagoon system, often it's rather for the greenhouse gas emission point of view, and often I've seen they just burning it, having a torch, because where the wastewater treatment plant is, there usually no people living who could utilize the gas. So finding a good utilization concept, it's always honestly a challenge. If we're looking at the household level, we have projects, or let's say we have regions, they have a payback time of less than 3 years. But not by the gas, usually when they have septic tank installed and there needs to be frequent sludging and so on, then it's helps to bring down the cost with the system if they have a full wastewater treatment plant with gas. The gas alone generating, this is really much relies on the context. I can't give a clear number. I have another project I can tell you we have done in Nepal, where we're putting sewage sludge into commercial biogas plant, and only the sludge component is paid back in 5 years by the extra gas we're producing. But there's big biogas existing, and we're just coming with an additional feedstock into it. So financially, we need to look at each case.
And the cost of energy in the Caribbean generally is very high, except maybe in Trinidad, but generally very high cost. So you get a better payback in countries where the energy is very cheap.
Because you rely on diesel and this kind of fuel, isn't it?
Yeah.
Mm-hmm.
Yes, good evening, sir.
Good evening.
In terms of having one of these plants in a community, how easy was it to get the public to accept it in terms of some of the maybe air pollution you would get from such plant?
Okay, it's an anaerobic system and you produce biogas. If the biogas it's not utilized and it's just bubbling out, it can create smell. It's correct. So technically, it's we capturing the gas and we burning it. If this is not working for any reason, usually we have a small air filter involved, which just takes out the odor. But this is more for the acceptance point of view. Otherwise, you need always, if you put wastewater service in a community, let's say a low-income community, you need your social team involving community right from the beginning, even sometime in the technical choice, also where you put the pipe. If it's a high-end community, usually they're just happy to pay your bill, the water bill, and just tell me when you put the pipe. In In low-income communities, our experience is this community is so sensible, and also land ownership often are not 100% cleared. You need a very strong involvement, even where you put the pipe, where you put the settler. And then you need to find out, okay, there is a system, will it smell? Will come the truck and emptying it? Will it affect my daily life? And then you think about, okay, this community who is next, or this people household, are you interested, for example, to take the biogas because you cannot serve the entire community, only some few? And are you also happy sometimes to look after the plant? So things needs to be really nicely communicated right from the beginning. And if you have exposure with it, do it, show them what is actually to come. It's not something you should impose and say, yes, you should be happy because you get no service. So community involvement is quite crucial. And it takes a lot of also human resources, time resources. Does it answer?
Yes, thank you.
Any other questions? Anybody else? We don't seem to have any other.
I have a question.
Yes, please. You go ahead.
How is this topic biogas in the Caribbean? I know there is a biogas community, but in combination with sanitation and wastewater from the utility point of view, are there projects? Are there thoughts? Are there something being implemented? At smaller scale, bigger scale, or yes or no?
Well, to the best of my knowledge, I don't know of any of the utilities that have necessarily introduced any biogas systems to date. I stand corrected. But what I know in the agricultural sector, there have been attempts at promoting it on livestock farms.
Yeah.
Among particularly pig farmers and cattle farmers in many parts of the region, with some degrees of success in some, but minimum adoption, as it were, because I think way back in the 70s, we've had the introductions of various forms of biogas digesters, but it is
smaller
never,
one, no?
Yeah, but not in the water and sewage systems, not the sewage systems, no, not to the best of my knowledge. No.
You have to remember as well, Andreas, that we don't have a lot of wastewater treatment plants or anything to begin with. There's a lot of, not even much primary, let alone secondary or tertiary treatment on wastewater.
Yeah, it's mainly lots of septic tanks. There in places such as Trinidad and Tobago, you probably have about 30% coverage. Again, that is in a lot of the cities and similar to Jamaica, but most of the Caribbean, it's mainly smaller type domestic systems and package type plants in the hotel sector.
So, but hardly in the sewer networks either, then, no?
No.
Or you have sewer networks in the sea outfall.
Yeah, not very extensive sewer networks, no.
Yeah, there are some. The wastewater treatment plant in Barbados, I was just involved in the consultation on their upgrading, and obviously renewable energy was part of what we looked at in that. So it's slowly coming, but when you haven't got any wastewater, I think we've got somebody probably from Antigua on the line, but it's been donkey's years that they've been doing many feasibility studies, but still don't have a wastewater treatment plant for their main area even.
So theoretically, if you have a lot of on-site sanitation, you could potentially think of promoting the private sector coming in with more cost-effective mass product on septic tanks, with more advanced septic tanks, bringing me better quality, and as well with the biogas function involved, could help improving wastewater management, and later on, if you start putting a sewer network, you can just take the effluent from this prefab septic tank, and you just have the gray water treatment in the end and not the entire black water. So this concept might be worth as well looking into it.
Yeah. The other problem in many of the islands is that the topography it's very hilly.
Yeah.
So there's not a lot of space. I mean, Barbados is different because they are flatter, different topography. But where you've got such mountainous regions, finding the space to be able to put in systems is always challenging.
Even septic tank?
Oh, well, there are lots of septic tanks.
There are septics and soakaways.
Yeah.
But
yeah, and recently there have been a few projects that, for example, under the Jeff Crew Plus, looking at some of the constructed wetlands concept, and we just have one just recently launched with a project including St. Lucia, Dominica, and Cuba, introducing or trying to do some pilots on the constructed wetlands, but still it is just mainly septic tank systems.
Yeah. So constructed wetlands are fantastic systems, but they need space.
Yeah.
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 So that's why I thought about just from your point of view, I mean, you have to protect your water resources, and all this on-site system are pollutants to your water resources. And if you cannot pipe them, then looking an option how the on-site system can be improved. And what I see really, you can tell people go for a better septic tank, but in the end, if it's not cost effective, if there's not, let's say, a prefabricated solution, which is much cheaper than the Mason brick built stuff. So this prefabrication on septic tanks, something I have seen in many countries, can really help to improve on-site sanitation and the pollution.
Mm-hmm.
Yeah.
And the audience we have here today, they're not as involved in the septic tanks because they're part of the utilities. So we're looking at the larger system. That's why the lagoons is an interesting concept. I mean, in St. Lucia, we do have the lagoons, and it's something that putting in the process is a possibility. I know I'm not sure it's Ezekiel or Shannon asked a question, about the energy recovery. And I know in Kelowna, Mike Gosden will be one of our featured speakers on the webinars one day, and he'll talk about their system. But I'm used to it. I'm not sure that I haven't spoken to him lately, but were funding or paying all of the energy costs in their wastewater plant, which is, of course, normally one of your biggest municipal areas of energy. And also they were giving the energy to the local schools and heating the local schools and providing air conditioning. So there is the paybacks there.
Yeah, you need to find a solution for that. It will not come automatically. Just having biogas, it doesn't help. You need the concept.
Yeah, I think what's most important is that as our countries in the Caribbean move forward and they are starting to put in more wastewater treatment plants or even smaller decentralized systems, is that these are concepts that need to be taken into consideration. It's not just the treatment of the wastewater, but what can we do with the sludge? What can we do with the energy recapture? So I think the talks that we're doing, that Ignatius is doing, it really helps us to open our eyes as to, okay, we should be incorporating at least the feasibility of some of these additional areas into our planning.
Well, I guess, yes, all of that is part of the exposure of the operators and the people within the utilities to know a lot of what exists in different parts of the planet, where some of these have been operated quite successfully, and offer you more options as we plan ahead. So that's one of the good things of having these types of webinars. And of course, for posterity, it is recorded and circulated to the participants, and who many of them are also doing the certification exams, and it helps them in the reviewing process, in the preparation.
Mhm.
So we really welcome the time that you have taken this evening amidst your stormy weather now, and I hope all remains well for you.
Yep.
I think in Trinidad, I'm told, I just read, I saw a pop-up that they were working hard to restore the power supply. So that should be all sorted out soon. And I'd like to thank you again, Valerie, for all the connections and finding us some resource personnel who can give us these very good presentations. And thank you all for joining webinar number 5 today. And thank you so much, Andreas,
Thank you for
giving
the
us your
opportunity.
time this evening.
All the best.
Yeah, I'm Ignatius Jha, Executive Director at CAWASA, and we're going to be signing out after a pretty good session this afternoon.
Very
Thank
good.
you. Have a good
Thank
evening
you.
wherever you
Goodbye,
are.
everyone.
Keep safe and
Bye.
well.
Yes.
Bye-bye.